For decades, humanity has stared into the vast, silent reaches of the cosmos, wondering if someone or something is looking back at us. The universe is incredibly large, and yet, despite our best efforts, it remains hauntingly quiet. This is the essence of the Fermi paradox. Should we be shouting into the dark? Or is our silence the only thing keeping us safe from the unknown terrors of interstellar space? Since the mid-20th century, our planet has been leaking signals. Television broadcasts, radio shows, and radar pulses have all been streaming away from Earth. However, these signals are weak. As they travel further from our solar system, they stretch, distort, and eventually dissolve into the background noise of the cosmos. To an alien observer even a few light years away, our earliest broadcasts would be indistinguishable from the random crackle of a distant star. If we want to be heard, we need more than just leaks. We need a beacon. A signal powerful enough to cut through the interstellar fog. Engineers propose using massive microwave beams. These concentrated bursts of energy could carry information across thousands of light years to specific star clusters. Building such a device is a monumental task. The technical precision required to aim a signal at a moving star system is staggering, but the technical challenge is only half the battle. The economic hurdle of interstellar communication is perhaps the greatest barrier we face. Maintaining a beacon for centuries requires a level of financial and political commitment that humanity has rarely shown for any project. We must ask ourselves, is the cost worth the risk? If we successfully signal our presence, will the response be one of friendship or something else? As we continue to listen, the debate rages on. Whether we choose to shout or remain silent, our future among the stars depends on this choice. Since the beginning of time, light has been our primary connection to the universe, bridging the vast gaps between distant stars and our eyes. But we are no longer just passive observers. We are now learning to use light as a focused, deliberate tool for interstellar communication. High on a desolate mountain peak, far from the interference of city lights, a massive laser array prepares to fire a message into the unknown. This is method 2 of the search for extraterrestrial intelligence. Optical communication through high power, ultra-short laser pulses. To reach the stars, we don't need continuous beams. Instead, we use femtosecond pulses, concentrating incredible energy into a fraction of a second. In that brief moment, the laser can become so bright that it momentarily outshines its host star to a distant observer. From the perspective of a planet orbiting a far-off star, our sun would appear to flicker with an artificial, rhythmic intensity. Unlike radio waves, which spread out and weaken over distance, laser light can be focused into a tight, incredibly narrow beam. This precision allows us to target individual star systems thousands of light-years away with unprecedented clarity and signal strength. By aiming at specific exoplanets found by telescopes like Kepler and Webb, we increase our chances of being heard by a local civilization. However, this technological feat comes with a significant price tag and extreme energy requirements. Generating pulses that can reach across the galaxy requires power levels comparable to the entire output of modern cities. Every message we send is a massive investment of planetary resources. Scientists must weigh the cost against the potential of first contact. If our aim is true that light will eventually reach its destination, descending through an alien atmosphere as a mysterious beacon, whether anyone is there to see it remains the greatest question of our age. We continue to signal, hoping for a reply from the dark. The search for extraterrestrial intelligence is more than just science. It is a testament to our desire to find our place among the stars. Space is an ocean of silence, and for decades, humanity has searched for a way to scream into the void and be heard. We've tried radio waves and high-powered lasers, but these methods require constant energy and precise targeting to work over vast distances. But there is a simpler, more permanent way to announce our presence to the galaxy: the solar billboard. Using the transit method. Imagine launching a massive ultra-thin sheet into a stable orbit around our sun. It acts as a physical blockage of light. As it passes in front of the sun, it creates an artificial dip in light that distant astronomers would perceive as a transit. Unlike natural planets, which are spherical, these billboards would create unique light curves that look undeniably artificial to anyone watching. The beauty of this method is feasibility. Once deployed, the billboard requires zero power and can signal for thousands of years. Studies suggest that humanity could realistically construct and launch such a structure within the next 100 to 200 years. This signal would be visible to any civilization located within 1,000 light years, provided they are looking in the direction of our transit. Now flip the perspective. What if alien civilizations have already done this? What if they are waiting for us to notice? Alien astronomers might be observing our sun right now, seeing a rhythmic, geometric flickering that tells them, life is here. This is why SETI researchers are now looking back at existing exoplanet data, searching for geometric anomalies instead of just spheres. The discovery of a single solar billboard would be the most significant moment in human history, confirming we are not alone. The stars are no longer just points of light. They are the beacons of the galaxy. Let's keep searching. Like and subscribe to the channel so you don't miss out on many interesting and useful videos about the mysteries of the universe.